Hi, and welcome to MSc. In this video, we're going to be looking at the domain and range of functions and relations. So the domain of a relation is the set of values defined by the independent variable. So this is going to be the variable that's along the horizontal axis. It's typically, or by default, would be your x variable, although it doesn't always have to be x. It could be a time variable or something else that is the independent along that x-axis. The range is the set of values that make up your dependent variable. This is your vertical or typically your y-axis. Again, it doesn't always have to be the actual letter y. It could be any number of other things, such as height, for example. So when we define domain and range for relations, in this case, this function, this straight line, we're looking at defining the sets of values that make up those domains and range. So for this example here, we have the function y equals 2x minus 3. That's this line here. These lines, these graphs were created in Desmos, which is an online graphing tool. And if you've never used Desmos, you should definitely check it out. I'm in no way sponsored by Desmos at this point, but it is a great online graphing software tool, and it has a lot of versatility. So these graphs were created, and this is y equals 2x minus 3. And so if we're going to look at the domain of this, and I added arrowheads here indicating that this graph is going to continue on. It's important that it doesn't just terminate for what we're going to do next. Let's look at the domain. So I'd say, okay, well, the domain is going to be the set of values. And we're going to look at defining this as my x, my horizontal independent x, and this is my vertical y-axis. So we're using set builder notation here. It's the set of x values such that x is an element of the real numbers. This is a continuous line graph. There's no breaks in it. It's not only the integers. It is a continuous graph with no breaks. And so there's really no limitations on what x can be. X can be any real number, and I can sub it in here, and I'll get a value. So that is my domain for this graph. Likewise, for the range, my range is the set of y variables. Y values such that y is an element of the real numbers. Again, there's no restriction that I have on the y values, so it can be anything I want. If I were to use, instead of set builder, if I were to use interval notation, then this can go from negative x, being way down here at negative infinity, all the way up to positive infinity. So we use the rounded brackets whenever we have infinity values, and my interval notation, which assumes that we're part of the real numbers, would look like that, and it would be the exact same for the range. So the domain and range here would look identical. If you haven't checked out the videos on set builder notation or on interval notation, you should certainly go and do that and then come back and finish this video off. So this isn't super interesting in the fact that there's no real restrictions. We can basically have any x value we want, and it can generate any y value we want. So let's add a little nuance to this. Let's say that we had a hole in the graph. And let's make the hole in the graph right here. So let's say there's an open circle right there. And really what we're saying in this part of the example, which will be kind of a second example here, we're saying x cannot equal 4. So now we're introducing this restriction. We're saying x cannot be 4. And by a product of this, if we sub 4 in, we'll see 2 times 4 is 8 minus 3 is 5. And you can tell, okay, why 5 on the graph here. You can see that line lines up. And so we're also saying, as a result, that, and therefore, y cannot equal 5. Right? So this graph can't be x equals 4 or y equals 5. What would that do to my domain? So let's take a look at the domain now. the domain would change. We'd still have the set of x values, such that x is still an element of the real numbers, but now we'd have to put the restriction before we close the bracket. And we'd simply state the restriction as x cannot equal 4. We don't need to use greater than or less than pieces here because it's just one point that it can't be. It can be everything else. Similarly, for the range, we have the set of y values such that y is an element of the real numbers, and we put the restriction where y cannot equal 5. So that would be rewriting the domain and range for this new function that has a hole in it, which would have to be defined slightly differently than the original, that has these restrictions. This would then become a little bit more challenging to use interval notation. So interval notation, what we'd have to say is, well, we have this situation where we have two intervals. I have negative infinity up to, for x, up to 4, but I don't want to include 4. And I also have now from 4 up to positive infinity. And it would actually be the union of those two intervals for my domain. Similarly, for my range, I would have negative infinity up to, but not including 5. So I use my rounded brackets, and it would be from 5 to positive infinity, and that would be the union of those two intervals. So here's another example to look at. And again, we'll add arrowheads to this graph indicating that this graph continues on. It's a parabola defined by 0.5 times x minus 4 squared minus 7. Let's also label this as x and as y. And then we'll start our domain and range. So the domain is the set of x values where x is an element of the real numbers, and there's no constraints. I can sub absolutely any value of x in here, and I'll get a y value out. So there's no restrictions there. For the range, we'll say, well, the range is the set of y values such that y is an element of the real numbers, but there are restrictions. We notice here that we have a minimum value because this parabola opens upwards. So the minimum value I can have is the -7. And so we can say that y has to be greater than -7, and it actually can be equal to 7. It can be equal to -7 when x is 4. This first term goes away and we're left with -7. So we have to write the equality piece of that, and then we'll close the bracket. So we're saying y, such that y is an element of the real numbers where y has to be greater than -7 or equal to -7. Okay? So we have a bit of a more interesting restriction here than we certainly did with the plain regular straight line. However, in some word problems, sometimes what we'll find is we'll find restrictions that make sense for the problem itself. So we could have a restriction where x had to be greater than or equal to 0. This is quite common if we have time, especially along the x-axis. We might get a nice parabola, but the part here in the negative time doesn't mean anything to us, as an example. So let's redefine this now, looking at this restriction being in play. Well, that would change our domain to the set of x values such that x is an element of the real numbers, and we'd have that restriction here where x has to be greater than or equal to 0. Again, very common in a lot of word problems where those negative values might not be as meaningful. The range then doesn't actually change. The range could still be from -7 all the way up. So the range is not affected by this restriction. And we'd say y is an element of the real numbers where y still has to be greater than or equal to -7. If you'd like to try writing these out using interval notation, by all means, you can try to do that. If you want to pause the video here and see if you get it right, I'll put them in here for you. Let's start up here at the original function that was allowed to go into the negative x values. This interval notation would be negative infinity to infinity. And again, we use rounded brackets. For the y, we would have negative 7, and we'd have infinity. And we know we use rounded brackets with the infinity, but the 7 negative is included, so we'd use the square brackets. For the domain here, we go from 0 all the way up to infinity. Again, infinity is always that rounded, and the 0 is included. And of course, just like above, the range does not change, and it will look just like it did above. So hopefully this rundown of domain and range has helped to look at some graphical examples using both set builder notation and interval notation. Thank you very much for listening, and thank you for watching.